This is the first subcircuit of the project. In here we're seeing the visualizer. Due to problems with the 7448 chip, I did it completely using AND, NOT and OR gates. You can see the different bit inputs here and the outputs are here. First you have to enable them, and then you have the different bits. For example, 001 represents number 1, this represents number 2, number 4, number 3 and number 1. And if you keep everything in 0, it represents number 0, excluding the bar in the middle that represents the full circuit. If you see it like this is the full circuit here with each of the outputs and each of the inputs and the enable. This is my register, and we're going to see it has dBs tables and 3 inputs, 3 outputs. We're going to enable and see it work. We're going to store number 4. We can just use the clock and see that it works. We store number 3, for example, and it also store it. We're going to see the reset, and it's going to reset it, and if all is 0, everything is 0. It's really simple and really useful. Here we have the codifier that transforms the different floors to a 3-bit output here with the different bits, bit A1, B1 and C1. We have different floors, floor 0, floor 1, floor 2, floor 3 and floor 4. We can start to text it. We have 0. If we activate 0, nothing happens. We still have a 0 output here. If we activate 1, we have 0, 0, 1, which means 1 in 3 bits. We have 2, we have 0, 1, 0, that is 2 in 3 bits. If we have 3, we have 0, 1, 1, that is the number 3 in 3 bits. And number 4 is 1, 0, 0, that it means 4 bits in 3 bits. And that's all for the codifier. We didn't use any chip here, we did it all raw because it was simpler to do with the truth tables and we didn't want any problems in the process, and that's all. But at the beginning we did it with 4 bits and it didn't work for this project, so we had to change it and it was really difficult to do.
Let's start with the counter. The counter has several inputs: BUD, CLK, E, RMAN, and LIMT. Each flip-flop designates 1 bit. To decide if the value should change, bit up and all previous flip-flop outputs are checked. If they are all true or all false, the value will change. Either that, or if the value of the flip-flop itself is true. Then at the bottom we check some conditions, like is lim and is 7, to make sure that it resets whenever those conditions are met. And then fin de ciclo, which checks for the end cycle of the counter. This is the mem button. It's literally just a flip-flop. This is the main circuit. We start with the buttons, all attached to their mem buttons. The output of that gets sent to the codifier, which serves to tell the counter where we need to go. The counter gives its output to the register, which sends its output to the visualizer, which makes sure that we can see what floor we're on the 7-segment display. If you look besides the 7-segment display, you'll see another counter. This one serves as a clock for the first counter. When NSYC, or fin de ciclo, is activated, it will send the clock signal to the first counter. Let's backtrack to the buttons for a second, because there are some important details that should be explained. The buttons are restricted in such a way that if you are currently on the floor 0, you cannot press the floor 0 again, you can only go above. And if you are in any of the floors above 0, then you cannot go to any floor except floor 0.